Kia ora, and welcome to a lesson on Cambridge Mathematics P3, the use of partial fractions and integrations. Today we're going to look at how we can take a complex fraction, like the one in example 1 here, and solve the integration of this by using partial fractions. So the first step is to obviously transform our equation here into partial fractions. So if you can't remember how to do that, there is a video that you can go back and watch. However, I'm not going to be going over it in great detail today. I'll just be doing it. So we have 3 minus x over x plus 1 x squared plus 3, and we're going to set this up as a over x plus 1, and because this is x squared plus 3, we're going to have bx plus c over x squared plus 3 times through to get 3 minus x is equal to a x squared plus 3 plus bx plus c times x plus 1, which becomes 3 minus x, a x squared plus 3 plus b x times x plus 1 plus c times x plus 1. Okay, now we need to do some cancelling out. So I'm going to start off with saying let x equal minus 1, so that I get rid of my b and c term. So let x equal minus 1, so we get 3 minus 1 is equal to a minus 1 squared plus 3, and the b term and the c term will disappear, which is going to leave me with 4 is equal to 4a, so a is equal to 1. Now I need to get rid of one of my other terms, so I'm going to get rid of the b term, by making x 0. That'll cancel that out. I know a is 1 now, so I can use the substitution of a is 1 to solve. So we get let x equal 0. We end up with 3 minus 0 is equal to a is 1 lot of 0 squared plus 3 plus c lots of 0 plus 1, because the b term will disappear with the 0 multiplied through, which is going to give me 3 is equal to 3 plus c, giving me c is equal to 0. And the last substitution, there's no more cancelling out that I can do, so I'm just going to make x equal 1. So I get 3 minus 1 is equal to 1 lot of 1 squared plus 3 plus b lots of 1 plus 1, and that's it, because there's 0 in the c term. C being 0 means that there's nothing left on the end, which gives me 2 is equal to 4 plus 2b, which solved gives me b is equal to minus 1. So the integration that I'm actually going to be doing then is the integral of a, which is 1 over x plus 1, plus b, which is minus 1, so in fact let's change that to a minus rather than a plus, so minus 1 over x squared plus 3, x squared plus 3, and that's not minus 1, it's actually just minus 1x, which is just minus x. Okay, from here we're going to integrate this. 1 over x plus 1 is easy to integrate. That's just log mod x plus 1. However, x over x squared plus 3, that needs to be sorted out first. If you treat the x over x squared plus 3 as the differential of function x over function x over k, then you're going to be able to integrate this. So we're going to split this into the integral of 1 over x plus 1 minus, so if f of x is equal to x squared plus 3, the derivative would be 2x. So I need to have a k value of a half. So this will be minus a half of the integral 2x over x squared plus 3. And if you remember the rules for the integral of this, that just is going to become k log f of x plus c. So we're going to be left with log x plus 1 minus a half log x squared plus 3 plus c. And that is our final solution for that question. Okay, so there's a bit of tying it into previous lessons, obviously previous lessons on partial fractions and a previous lesson on the integral of k of the derivative function over function. Okay, let's have a look at another question. Okay, example 2, find the integral of 9 over x plus 2 x minus 1 squared. So I'm going to skip through the partial fraction bit. If you're wondering how to get there, go back and watch a partial fractions video. But what you're going to end up with is you're wanting to do the integral of 1 over x plus 2 minus 1 over x plus 1, sorry, x minus 1, plus 3 over x minus 1 squared. Okay, the 1 over x plus 2 will be an easy enough integral to do. Log will be how you do it. The minus 1 over x minus 1, again, will be an easy one, will be a log. But the 3 over x minus 1 squared, we won't be able to use with a log. So what we're going to do is reverse chain rule. So first thing I'm going to do is just rewrite the 3 over x minus 1 squared. So this is going to become 1 over x plus 2 minus 1 over x minus 1 plus 3 lots of x minus 1 to the minus 2. Okay, so my solution for this is going to be log x plus 2 minus log x minus 1, and then reverse chain rule, so add 1 to the power, divide by the power, and divide by the differential of a bracket. So we're going to be dividing by minus 1, and we're going to be dividing by the differential of x minus 1, which is 1. So all that's going to do is change my plus 3 to a minus 3. So this is going to be minus 3 x minus 1 to minus 1 plus c. Last thing to do is just do a bit of tidying with your logs. So this will simplify down to log x plus 2 over x minus 1 due to your log laws. And I can rewrite with minus 3 x minus 1 to the power minus 1 as 3 over x minus 1 plus c. Okay, so if you're wondering how we got this, again, that's partial fractions. Go back and have a look at that lesson on that. But once you get your partial fraction, it's very straightforward to solve. Okay, thank you. Hopefully you can use this video now for your questions, and I'll speak to you again soon.